Okay guys, we're going to do chapter 10, section 2 on friction, gravity, and elastic forces. So press pause if I go too fast for you. So friction is the force when two surfaces are rubbing together, the force that they exert on each other. And they usually act in the opposite direction of the motion. So the strength of the force of friction depends on two things: the type of surfaces involved, if they're smooth or rough, and how hard they are pushing against each other. You got static friction, which is the friction that acts on objects that are not moving. Like a car doesn't move because when it's not in motion, it's because of static friction. Sliding friction, when you're just sliding something across another surface. You've got rolling friction when you have a skateboard, for instance, rolling across the street. And then fluid friction, it would be when you are when you have a solid moving through a fluid, like a fish or someone surfing. The factors that affect gravitational force between two objects. The gravitational force exerted on a person or object at the surface of a planet is known as its weight. So gravity is a force that pulls an object towards each other, and mass is the amount of measure, or the measure of the amount of matter in that object. So as we talked before, weight is the gravitational force on something that has mass. And remember, it's always measured in newtons. You can see here the weight on the moon and the earth, how they compare. The moon is less, so it's going to have less weight, but the mass is going to never change. It's going to be the same. The force of gravity between two objects, it increases with greater mass and decreases with greater distance. So if I have two objects here and they're fairly small, then they're not going to have as much gravitational pull as if you have two larger objects the same distance away. And the larger the object, the more mass it is, the more force that gravitational force that occurs between the two. If you have two small objects and they're further away, they do have a gravitational attraction, but because they're further away, then the gravitational attraction is not as much. And free fall. Free fall is the only force acting on an object is gravity. So this happens in a vacuum when there is no upward air resistance. So in free fall, the force of gravity is the only thing causing something to drop. So typically, when you have a smaller or a larger object here, one might fall at a faster rate, but when you have no air present and therefore no air friction, then they're going to fall at the same rate. Falling objects with greater surface area experience greater air resistance. So think of a leaf versus like an acorn here. The leaf has greater surface area, so there's more air resistance working upward on it. Gravity is the same on both, but there's more air resistance on the leaf because it has more surface area versus the acorn. A projectile is an object that's thrown, much like what we did in our marble launcher lab. And then the red and the yellow ball will hit the ground at the same time, even though one's going straight down and one's going in an arch, because they're considered projectiles. When matter is considered to be elastic, that would be when like tension occurs. So it can be, this is an elastic force. Compression means it's squeezing or pushing together. And elastic force means it stretches or pulls matter. That's called tension. So like in this fishing pole is tension, and this is called compression. And that's it.